For these notes, we're going to talk about two special exponent properties. The first one is when we have anything except for 0 itself raised to the power of 0. So as you can see here, we have 1 to the 0, 2 to the 0, 3, 4, and then x. X can represent anything to the 0 power, as long as, again, we don't have 0 right here. That's something extra special. So anything to the 0 power, most people think it's 0, it's actually 1. So 1 to the 0 is 1, 2 to the 0 is 1. All of these are always going to be 1. Not 4, not x, just always 1. For negative exponents, what happens is that means we do the inverse, which means it goes to the bottom. So we can think of this over 1. So this becomes 1 over x to the positive n then. So we don't ever want negative exponents. It's just kind of a rule we have in math. So to get rid of a negative exponent, it needs to go to the bottom of a fraction. So it says to write each expression using positive exponents. So we'll do this, and then evaluate, so get an actual number. Now again, it is possible to do these in your calculator, so you can do that to check. Most of your calculators will give you a decimal, so you'll need to remember how to change that into a fraction. Or you can just check yours, change yours into a decimal and see if it matches. All right, so 5 to the negative 2 becomes 1 over 5 to the positive 2. That's how it becomes a positive exponent. So what it means to evaluate then is 1 over 5 squared is 25. So 1 over 25 is what your official answer would be, but you do need to have both of these. All right, so for instance, if I want to check, if I do 5 to the negative 2, it gives me a decimal of 0.04. So I can either then do second PRB, fraction to decimal, decimal to fraction, and it changes it. Or if I remember 0.04, maybe I can write it down up here. If I type in 1 divided by 25, my answer, make sure they match. So you can either change it into a fraction or you can make sure yours matches. All right. Same thing, 8 to the negative 2 becomes 1 over 8 squared. 8 squared is 64, so 1 over 64. Okay. Negative exponents make our answer smaller. Number 17, 9 to the negative 1. 1 over 9 to the 1. Now, I wrote it really light because you do not need to put the 1. I would prefer if you didn't. So just 1 over 9, because then you're done. There's nothing else to evaluate. It's just 1 over 9. 18 is 1 over 4 to the 4th. So again, you don't want to type that whole thing in your calculator. You should just know that your top is going to stay 1. And then 4, exponent key again is this little caret, or the other exponent key on your other ones. 4 to the 4th is 256. So 1 over 256. So I'll look again to make sure. 4 to the negative 4th is that really yucky decimal, so I'm just going to hope that's right. 1 over 256. And yep, those two are the same. So that's how you can check your answer to make sure you did it correctly. Number 19, 1 over 10 to the 3rd. And then again, your numerator is going to stay 1. 10 to the 3rd is 1,000, so 1 over 1,000. Number 20 is 2 to the negative 7th. So 1 over 2 to the 7th, 1 over, and then do 2 to the 7th in your calculator, and it becomes 128. 1 over 128. Again, I am not checking my answers, but you definitely can. 21, we have two separate ones, so you just do it all at once though. You don't need to have two separate fractions. I'll show you both ways. If you do it separately, you would have 1 over 4 to the third times 1 over 7 to the first, which again is just 7. We should know from multiplying fractions, we multiply straight across. So 1 over 4 to the third, again, you can do this separately or all at once. 4 to the third is 64, and then times 7 gives us 448. So 1 over 448. Again, I'll do it over on this side. If you would like to take it and do it all at once, or sorry, all separately, you would do this. 1 over 4 to the third again was 64 times 1 over 7, and then you could go here. Hopefully you don't need to take that, but you can. You also, instead of writing it out separately, since they both go to the bottom, you could just go 1 over 4 to the third times 7, and then change it back to this. So you can actually just make one big fraction to start with. So let me do that for 22. These are both negative exponents, so I know they're both going down. So 1 over 5 to the fourth times 3 squared. Again, if you don't like that and you want to do two separate fractions and then combine them, that is totally fine. 1 over, again, this is up to you if you need to do these separately. Otherwise, you could do 5 to the fourth times 3 squared, or 3 to the second, and we get 5625. So that's going to be a very, very small number if we type it in. That's what it looks like. '23 is a little bit different. Notice our first one does not have a negative exponent, but our second one does. What that means is the first one stays put. Instead of having a 1 for your fraction, this is just going to be your numerator. So I'll show you two different ways. If you want to write it all out, this is what it would look like. 3 to the fourth times 1 over 9. Then you would have to multiply them together. To me, that's more confusing, so I actually don't do that. I can see, oh, the positive one stays on the top. So this is 3 to the fourth over 9 squared. So that's how you want it to look. You don't want to leave it like this. If you separate it, you need to get this first. Then we can go ahead and evaluate. So 3 to the fourth is 81. 9 squared is also 81. 81 divided by 81 is 1. So to get full credit for this problem, you would have to have that and that for sure. '24 has even more stuff. Negative exponent, so that needs to go down. This is a positive exponent, so you can either put like an up arrow to show you it's the top of the fraction, or it stays put. Now we have a 0 power. Again, this doesn't make it 0, then the whole thing would go away because it's multiplication. This cancels to a 1, not a 4, just a 1. So essentially anything to the 0 power goes away because we're multiplying by 1. So 10 squared is on the top, and then 8 to the positive third is to the bottom. Remember, moving it down is what changes it to a positive exponent. So 10 squared is 100. 8 to the third power is 512. So we will need to simplify that. Again, in this calculator, you can just do 100 ABC 512 and hit enter. 25 out of 128. And again, if you want to check your answer, you can type that whole thing in. 8 to the negative third times 10 squared times 4 to the 0. You can type that entire thing in, and I get this yucky decimal. Now let's see what happens when I do 25 divided by 128. It's that same decimal. All right, these last ones with variables, you just will not have to come up with a final number for an answer. Although if you look at 28, it has a number and variables. All right, so for number 25, again, we have a negative exponent, so that goes to the bottom. There's nothing on the top, so it's a 1 over, x to the 9th in this case. That's all you need to do. Same thing, a to the negative 4th, so 1 over a to the 4th. When we look at 27, we have a negative exponent, so that needs to go down. We have a 0, so that cancels to a 1, and then a positive exponent stays on the top. So t to the 11th stays on top, r to the positive 6th then on the bottom, and that's how it stays. 28, negative exponent, positive exponent. So n to the 5th would stay at the top because it's positive. 3 to the positive 3, m to the positive 4. So you do need to change 3 to the 3rd into a number down there. So n to the 5th is on the top. 3 to the 3rd is 27, m to the 4th for your final answer. So when you're doing these, make sure you have no negative exponents as your final answer.